Hello. If you ever thought of preparing for maths or coding Olympiad in high school, or for a job interview where your creative and problem-solving skills are going to be assessed, you've probably heard of game theory problems. Not to speak of their numerous practical applications in social science, economics, robotics, software engineering, etc. In short, those problems often come down to finding a winning strategy for one of the players. As complex as it may sound, there are actually a few general ideas that often help. One of those is a symmetric response principle. So consider a game on a round table with a round hole in the center, where you and your opponent take turns to put identical coins one after the other, in such a way that they are fully located on the table surface without any overlaps. The game continues until one of the players can't find a valid spot to put the next coin, and then the other player wins. So here's the game. Assume unrestricted supply of coins. Can you formulate a strategy for either of the players to win for any actions of the opponent? This might sound somewhat complex, as there are numerous options for the opponent moves. So can we ever account for all of those scenarios? Well, we actually don't have to, as long as there is a general principle to guide us. What if we simply mirror all the moves of the opponent? Namely, reflect them symmetrically about the center of the table. We can always do so if we play for the second player, as in the beginning and after each of our moves, like now, the table setup remains symmetric about the center. So if the opponent can find the spot, we are guaranteed an available symmetric spot due to the symmetricity of the setup. This way, after each move of the opponent, we always have a move. But the game can't last forever, as the table space is finite, so at some point the opponent runs out of moves, and here we win. So the principle of symmetric response can lead the second player to victory no matter what the first one does. Note, however, that the first one can't use the same strategy, as the symmetry of the setup after her first and consecutive moves can't be guaranteed. Note, however, that having a hole in the center of the table was absolutely essential for the strategy. Without it, the whole game flips. As now, the first player can start from occupying the center of the table and then proceed with the exact same strategy, reflecting all the moves of the opponent, just like we were doing before when playing for the second player, using symmetric response strategy. But now the strategy works for the first player. So whatever the second player does, the first player has a symmetric response until apparently the second player runs out of moves. And now the losing party is the second player and the winning party is the first player. So symmetric response principle could actually work either way depending on the game setup. And of course, it's not a universal solution. Not all the game strategies could be implemented based on it. But subject to appropriate modifications, this is perhaps one of the most common principles. So I would always start with considering it whenever appropriate. Hope you'll find it helpful, and stay tuned for more ideas to discuss.